let's move on to another fellow here, our clown. He's a clown. He makes me he makes me laugh, some of the answers he gives, and I love it. Absolutely love all that he's got to say. So here's the first thing he criticized. Criticizing the rope model, okay? And by the way, we encourage people to criticize the rope model, hopefully from a rational point of view and not like this fellow who comes up with all kinds of nonsense. But, we do want criticism, and I'm going to have an example at the end of this fellow who asked a question about ionization, and I'm going to answer him today. But let's go with this fellow first, and here it goes. He says the following. He says, Bill's ropes are invisible and untouchable, or intangible, right? It's inconsistent with observation and experiments. Absolutely. Yeah, it's totally inconsistent with observation and experiments. You can't go out there. Here I have a little fellow. Okay, he goes out there. He's a particle mathematician. He's going to go to the lab right there over there at CERN in Switzerland. He's going to observe particles. He's going to observe energy. He's going to observe fields. Yeah, you can't observe concepts, So in this sense, they're all blind. They can't see the stuff they're working with, but they insist on going to the lab and running an experiment. Why are they running an experiment? What's that going to tell them? I mean, if it gives them a clue, that's fine, but then you have to go back to your desk and figure out, what thing Mother Nature was using to do her magic. You can't just go in there and say, oh, I observed, I saw with my eyes. Now, as you can see, the rope is intangible. Let me prove it to you. Again, I like to prove this to you, okay, so that I can convince you and make sure you are convinced and educated and finally know. A spoon, you let it go of it, falls to the floor, and something is attracting it downwards. Some people say it's pushing, I say it's pulling. But either way, we can find out that there's nothing that you can touch or see here, nothing that you can touch or see there. And if you're saying nothing came in contact with a spoon, then you're doing black magic, okay? Because you're saying Mother Nature is not, she's a bitch, but she's also a witch. No way. She could be a bitch, but not a witch, okay? Okay, so this fellow continues. He says, we differ in our definition of science. Absolutely. Yeah, I don't know what science he studied, maybe at the monastery. Makes no sense, whatever he comes up with, and we'll see some examples today. I hope to cultivate in emergent scientists a spirit of fearless inquiry, coupled with a commitment to hypotheses that can be what? Tested and falsified. I was going to say reified. Tested and falsified. He's saying that science is about testing and falsifying. Okay, so we're going to falsify everything here? I mean, what is he talking about? You're going to falsify, right? Okay, think beyond the orthodox. Challenge authority, just like he did. He believes everything from authority. He's telling you to challenge authority. But hold to the standards of what? Testability and falsifiability. Well, falsifiability was created by Karl Popper, and he came up with this notion that science is falsifiability. Falsifying, that you want to falsify or try to falsify something. And a lot of people have the same notion that skepticism has something to do with science. No, skepticism, verification, falsification all have to do with religion, only with religion. They have to do with belief, with what you believe. You falsified God, the other guy says you didn't. The other guy continues to believe in God, so who's right? I mean, again, science has nothing to do with skepticism or belief. That's again part of religion, not science. And so, yeah, he thinks that those are the two criteria: testability, and as far as testing, we have a problem there as well, because, like I just said, you throw the pencil and what test are you going to run? They've been running tests on gravity for since day one. Here's the experiment, okay? There it is, testing. Let me test it again to verify, right? Okay, so what caused that to fall down? I mean, we can't see it, we can't touch it, And so whatever you propose had better be invisible and intangible. Otherwise, you're not imitating what Mother Nature has out there. If you come from the lab back and say, I observed the mediator of gravity, we know you're lying. We know you're lying. You can't observe the invisible. You can't touch the untouchable. And so, as far as Mother Nature is concerned, we're all blind and quadriplegic. We can't see or touch anything in the lab that serves as a mediator for all these phenomena. And so that's where the problem is. Unless you come to grips with that whatever's there is invisible and intangible, you won't resolve it by going to the lab, testing, running an experiment. You got to go to your office, okay? Close your eyes, one beer, a little girl, 20-year-old girl, right? Beautiful girl for inspiration. And you visualize. You try to imagine what Mother Nature could be using. That's the way it works. Okay, so here, one issue that we were trying to address the other day, and he's got the answer to it. That's so great, that we have all these great thinkers out there. It says light bends because you have light going into a prism, and then it kind of bends sharply. It doesn't bend like a curve, it bends sharply like it was broken, and then it breaks again when it's coming out into all those colors, right? And he says light bends because frequency is conserved. And phase must match at the interface. At speed change, rotate at the interface, a speed change rotates the wave vector. Well, even if all the nonsense he just said is true, he hasn't explained it. That's a description. It's called a description. It's not an explanation. He hasn't explained anything. But he doesn't understand the difference between an explanation and a description. And he takes descriptions for explanation and says, oh, I've explained it. And he's not the only, establishment guru, right, or lover that does this. All of them are, they have no idea what the difference is between a description and an explanation. He hasn't explained the cause, the mechanism. He has not explained it. Then he continues, says, N lambda is higher in the blue, so blue deviates more. That's not an explanation. That's a description. It's called a description. The physical cause, okay, now we get to the physical cause of the bend is phase continuity at the boundary combined with a change in wave speed. That's not a physical cause. That's not an explanation. That is a description, okay? And again, that's where the problem is. If you don't know the difference between an explanation and description, we can ask you all day, and you're just going to think that you answered the question when you never did. And again, it shows how irrational people think, or if you can call it thinking, right? How they reason or try to reason in their tiny little minds. They first have to find out what the difference is between a description and an explanation. Otherwise, they're going to go around in circles until take you with them in that circle. So don't try to argue one of these people. They should be locked up in institutions, right? Okay, so here we have the famous mathematical language, right? Says the physical mechanism behind material dispersion comes from how bound charges in a material are driven by the light's electric field. Well, how can you bind? How can you use the word bound? Bind, we just discussed that a little bit, right? Unbounded, right? How can you bind something, which is a word of physics, when you're talking about concepts such as charges? What is a charge? 1.6 times 10 to the minus 19 coulombs. It's a number. That's what a charge is. They say a charge. No, that's ordinary speech. You can't use the word charge as a noun in physics, not formally. Okay, and then same with field. Field. What is field? Value at each location in space. So you're talking about numbers. And he's talking about binding charges to fields or who knows what. They're binding love with intelligence. Say, oh, love is bound to intelligence. Well, that's great for poetry, but don't bring it into physics. What are you talking about? In physics, this has no meaning whatsoever. Inertia and forces make their response frequency dependent. And again, those are descriptions. They have nothing to do with explanations. Physics is explanation, not description. And these people confuse the mathematical descriptions and they bring them into physics constantly, and they say, oh, we did mathematical physics, right? And that's when they come up with all these mathematical notions which they introduce into physics, casually, like indiscriminately, right? Okay, so here we have another issue there, and as far as math is concerned, here you have a situation. You ask a mathematician. I've had this in the past. You ask them, "What is this? This is a rock, right?" You say, "This is a rock, right?" And they say, "No, that's a mass." "Oh, this is a mass? I thought it was a rock." And no, for them, they don't talk about rock because that's too simple. That's too baby, too kindergartenish. So that's a mass, right? And they start talking about the kilograms and whatever. And you say, "This is a ball," and they say, "No, that's not a ball, Bill. It's 4 pi r cubed divided by 3." "Oh, I thought it was a ball." No, it's 4 pi r cubed, right? Divided by 3. They're talking in terms of volume, of mass, of lengths, and you're trying to ask about qualitative stuff. How does this universe work? I mean, why doesn't the Earth fly out of the solar system? You're talking about a physical object. Hopefully, the Earth is taken to be a physical object, right? A big physical object because we're standing on it. It doesn't fly out of the solar system. They say there's nothing physical that they can see or touch between the Earth and the sun. The astronauts have gone around there, and they said we don't see anything, nothing binding it, as they're using the term there, binding. So if it's not bound, why doesn't it, go out of the solar system? Why doesn't the electron fly out of the atom if it's not bound, physically bound? What's keeping the electron there tied to the nucleus? And they never answer those questions. They talk about action at a distance and mediate that distance, that separation, with field, with energy, with force, and other abstract mathematical concepts that have nothing to do with physics. We want to know what physical object is in there, keeping the electron from flying away, the Earth from flying away, the moon from flying away, and so on. And the big problem that mathematical physics has is they cannot explain pull, the force of pull. It doesn't exist in all of mathematical physics, never has. What they have is push. They have lots of push everywhere because they do everything with particles or waves, one-way waves, one-way particles. That means it can only press against something. How do you press at the same time that you pull? Well, the only way to produce pull is to put a mediator between the two objects. See how simple it was? And the only issue there is you got to make it intangible and invisible. And that's where everybody failed, because they could not imagine that there are invisible, intangible objects mediating between atoms. That's where the problem was. They never thought that was possible. Okay, nobody even considered it as a possibility to propose it, at least as a suggestion, let alone for people to believe it. Nobody proposed it. Okay, so here we have this fellow, and he continues. He says, "Bill, what's going on physically?" He's going to try to explain physically what's going on there. "Light polarizes the medium." It polarizes the medium. Yeah, we know that. I mean, why? And he says the field displaces electron clouds. Field displaces something? Numbers? What was the field? Bunch of numbers, right? Value at each point in space. Did I get that right? Or am I missing something? And he says displaces electron clouds. Electrons are bound, right? Physical, right? Bound. Electrons can follow the field. And what are we talking about? What's binding them? And how do they follow a field when field is a concept? So they have all this irrational language that they've created, and they want to get their message across. And nobody understands squat about this because it doesn't make sense. It's a irrational language that they've created. Okay, they want to talk irrationally in mathematics, no problem. You can keep it in mathematics and talk whatever you want over there, but don't bring it into physics and tell me that you've given me an explanation, that you explain the mechanism, the cause of the physical interpretations. No way. So none of this qualifies for physics. And so, what can I tell you? We have a problem with all these people because they brought this irrational language. They publish using this language, and people say, well, I don't want to read all that technical language. Okay, so we have all these people who serve as mediators and say, oh, we're going to translate what the mathematician said out there in his published paper, and we're going to make it available in kindergarten language for the public. And it's all poppycock anyways. First of all, it's all description. Whenever it's an explanation, it's irrational. Using the same words, field, energy, force, and so on, time. So they have all these irrational terms which they use to convey their theories to the public, and the public doesn't understand squat. And maybe that explains why people have finally forgotten about physics. They say, I don't care about all that nonsense. Yeah, because people have just been bored to death for all the nonsense they hear from the establishment. Okay, so here we have another situation. He says, Fizeau and Foucault measured light in slower in water than in air. Okay, so we know that, yeah. Supporting wave theory and contradicting Newton's corpuscular prediction. Okay, so great. So these guys were in the 19th century. Remember, Newton was in the 17th century, part of the 18th century. And so these guys are more advanced, and they proved Newton wrong, according to the mathematician. There it is. That's official, right? So Newton's particle died. We're done, right? No more particles. And so they said, he continued, double slit, thin films interference, and precise fringe visibilities are predicted by wave optics. Okay, so he's saying it's a wave. We're done. Light is a wave. Over and done with. But then he says, he contradicts himself, single photon. What is a single photon? It's a particle, known as a particle, right? Phenomena and quantizations. And again, quantity, they're talking about quantity, a lump of a value of a unit, a number with a unit. That's what a quantization is. They're talking about numbers, right? It says photoelectric effect, Compton scattering, anti-bunching, etc., all require quantized light, meaning single photon, meaning ball, little ball. And so, he's got a contradiction right there. On the one hand, he says, we've already proven that the particle is wrong, it's wave. And then he says, oh, by the way, some experiments show that it's a particle and not a wave. So what should we conclude? Is it a particle or is it a wave? Here we are. 400 years later, we still don't know. Not from the establishment, at least, right? So, yeah, we have a problem with all their language and what they claim to have proven. He talks about verification. Okay, what have we verified? It's a wave packet. It's a packet. It's a wave. What is it? Particle, corpuscle. What is it? A number? What is light? What mediates light? That's what we want to know. And then some people out there say it's a waving of nothing. So it's a wave, but of nothing. So the nothing waves. And that's what these people believe in. This is how they talk. It's just irrational chatter over there at the math club. Okay, so he says atomic force microscope imaging of molecular orbitals map onto quantum orbital shapes, probabilities. Absolutely not. No, probabilities we don't care about. Shapes we're interested in. But orbitals have shape, those round balls that you see there, you don't see a little electron bead moving around. Okay, that's what I'm saying here. That's not that atom that you see there is not what you see inside the pictures of atomic force microscope or scanning electron microscopes or whatever. And so we have a problem because these people are saying, oh, we mapped it. Yeah, you didn't map the little electron bead going around. And I'm showing just the hydrogen atom. I mean, we should be seeing little balls running all around there, right? That's what we should be seeing when we look through the microscope, right? Or these advanced microscopes. And that's not what we see. What we see is balls, right? That's what we see. And talks about, binding again. Stable nuclei are composed of protons and neutrons bound by force. Now, you can't bind by force. Okay, again, I put a prisoner there bound to the ball, not with a ball and chain, but by ball and force. Is that about right for physics? You're going to bind your leg to a ball with force, with energy, with field, time maybe, I don't know. I mean, you can't use concepts to talk about binding. You're going to talk about bound, I mean, you're talking about a physical connection. You can't say it's bound by force. But this is the language these people use, and they think they're being rational. They've been so brainwashed by all this language that they can't even get out of it. They don't even understand what they're saying anymore. And it doesn't make any sense because the language that they're using is totally irrational. But they just memorize the words and they just keep using them as if nothing. It never occurred to them to question whether, you can bind by force or vibrate a field or transfer energy or move a mass. It never crossed their mind to question the language. Okay? And so when you criticize the language, they say, oh, you're bringing word wizardry, word salad, and you're doing semantics and metaphysics and who knows what. So yeah, this is the issue. The issue is that they have a problem with language. They have to get their language straight if they want to convey their thoughts to the public, and they can't do it. They can't do it because mathematics is completely incompatible with qualitative notions. You cannot transfer, you cannot translate the mathematical notions such as field and so on and say, look, I'm going to take that same word and use it now to explain the physical cause, the mechanism. No, for mechanisms, you need objects, you need things, and field is not a thing, neither is force, neither is time, neither is energy. None of those are things. Okay, so this is where the problem is. Language has to change, at least as a minimum, right? And here's his last one. He says, what is time? Which is what we talked about last time, right? Last time we talked about time. Okay. You don't need to reify time as a material thing. But they do reify it. I mean, there's an example. Warp time. That's what you're staring at. That's what they did. They said, what is the cause of gravity? And they'll tell you out there, not me, okay? Everybody will tell you out there, anyone who is in mathematical physics. They'll say it's the bending of space-time, right? So we're talking about space and time at the same time. We're saying we're bending both of them. We're bending space, meaning length, width, and height, because that's what that little, those lines, that fishnet represents, and also time. So they're bending time. And then he said, we don't need to reify, but you are reifying when you give your physical interpretation. It's plain. I mean, you can't elude it. And you can't say, well, you're not supposed to take it so literally. What am I supposed to do with that? I'm looking for a physical interpretation of why this spoon falls downwards, and you're telling me it's a bending of time. That's what you're saying. Okay, so let's get that straight. That's the explanation that Einstein gave out there. He said it's the bending of time. Forget about space. Okay, so we got a problem because they're bending time. And what physical, and he says, what's physical are what? The invariants and the intervals. He thinks that's physical. I'm going to hit you with a baseball bat, that's physical. But I can't hit you with an interval or what? Or invariant. I can't hit you with an interval. Time is coordinate with a metric, whatever that means. No, it's not a coordinate at all. Coordinates are longitude, latitude, and altitude, and time is neither one of those, none of those. Time is simply a number line. That's what it was. That's what it's always been. And people confuse number lines with coordinates and dimensions, primarily those two. Okay, and then just in case, we had a second guy or a third guy there. He came over and he kind of synthesized the establishment. He put it in like 3 lines, and I loved it so much I said this is good as a punchline for what this other fellow just said, the clown, right? Here it is, and listen to him. He says, fields in physics aren't just abstract concepts. Oh, what are they? They carry energy and momentum. Whoa, have I heard that before? Right here on this channel, I've heard it before. We can measure, mediate the forces we observe. You observe the forces with your eye, like your 2 eyes or 1 eye, or how many eyes you use to observe forces, and transform consistently under relativity. So they're transforming forces or whatever they're observing them. And then he says the electromagnetic field, we're talking about field, right? And not a football field, not a poppy field. Here we're talking about the electromagnetic field, okay? Let's not confuse those. Is so real, whatever real means, right? Exists, that it exists, I guess, that its excitations, photons, right, are the particles of light. So they have these particles, these corpuscles of light, okay? They're going to do light with these corpuscles. And they're saying they're excited. I guess they move up and down as they move forward. I guess that's what they're saying. And so they have these excitations of photons, particles, little discrete packets of energy, which is a number, right? And he says that's the mediator of light. Well, you can't explain light with those particles, because when you do like the slit experiment, you have to put them at two places at once. And they say, yeah, they're at two places at once. And they just get away with that, and it's like if nothing happened. You know, the earth did not shake. So we have a problem because they're giving us an irrational interpretation, walking away like saying, hey, I explained it. Ha, you know. That's why the standard model, based on fields, makes predictions. Oh, the word predictions. That's the language they have. Energy, predictions, verification, falsification. They use all these words. They've just been so deeply brainwashed by all this garbage language, right? Makes predictions confirmed. And what are they going to tell you about the accuracy, the precision of how much they measured and so on? So you measure the table, right? It measures 2 meters and 1 micrometer because you measured it perfectly, right? And then you have it verified by someone else. Obviously, if you want it to be scientific, it's got to be measured by someone else. And the guy measures, he's got a better caliper, etc. And they say, hey, he's right. It's 2 meters and 1 micron. And so you say, okay, give me my Nobel. I measured the table. I mean, is he a scientist because he measured the table? These people say, oh, I measured it very accurately. Who cares? You haven't explained anything. I still don't understand how the universe works, how the micro world or the macro world works because of your measurement. So they think it's an issue of accuracy, of precision. It's got nothing to do with science. And then replacing all of this with threads, criticizing my theory, right? It's like throwing out the most successful science humanity has ever achieved. Successful? You mean like belief? Is that what he's talking about? See, all these people, they have all this language. They say, we are successful. No, you're not. You still can't tell me what gravity is. You cannot tell me what light is. You cannot tell me how the atom works. You cannot tell me, how magnetism works or electricity. You can't tell me anything. With all your language, with all your measurement, with all your verification and falsification and whatever, you cannot tell me how this universe works. We need to, and, one of the things you have to keep in mind, you have to do it what they call the classical way. You absolutely need to go back to classical physics if you want someone to understand you. If you're going to introduce quantum mechanics, meaning, magical mechanics, where you give properties to your particles that are not classical, meaning they're irrational, meaning they have to do with witchcraft and black magic, yeah, I mean, you can get away with murder as far as an explanation for the mechanism, for the causes. Because if you're going to introduce magic in there and say the particle can be at two places at once, or this particle can affect that one, entanglement without a mediator, you're doing black magic. And so you cannot explain it that way. You have to explain it for people to understand the mechanism. You absolutely need to go back to the 17th century, 18th century, 19th century. You have to go back to classical mechanics, because classical mechanics was attempting at least to try to explain these things in a way that we could all understand it with, mechanism, meaning with mediators and so on. And what quantum mechanics did, and relativity did, string theory also, is eliminate the mediator and say, we don't worry about that anymore. We're never going to figure it out. That's philosophy anyways. It's ontology, metaphysics, word salad, whatever they call it. And we're just going to do measurement and verification and falsification. And that's what we have today. We have a lot of falsification and no understanding.